Welcome to Easy BTech, your guide for BTech and beyond. In this channel, you can learn the subject very easily. So my name is G. Sampath. I am going to explain the subject VLSI design. Today, we are going to discuss the another programmable logic device. So that is PAL. So last class we discussed about programmable logic array. Now today, programmable array logic. Okay, programmable array logic. So programmable design approach of design approach of PAL. Okay, programmable array logic. Okay, so it is another type of PLDs, right? PLDs, programmable array logic. So PAL is defined programmable array logic. So programmable array logic. Okay, programmable array logic. So it is so number of gates design. So programmable array logic. So AND gate is programmable. In this AND gate is programmable. In this AND gate is programmable. AND gate is programmable. AND gate is programmable. Okay, AND gate is programmable. OR gate is fixed. OR gate is external. OR gate is OR gate is fixed. Okay, fixed and external. Fixed, it is external. Fixed, it is external. Okay, it is external. It is external. So PAL is a simple design for a manufacturers. So it is simple design. It is simple design. Only AND gate is programmable. So OR gate is externally connected. So OR is externally and inbuilt it is programmable. AND gates only programmable. So it is simple design for manufacturers. Simple design. Okay, it is simple design. It is simple design for manufacturing chips. Okay, manufacturing. Okay, simple manufacturing. So so PLDs are the advancing semiconductor trends. Okay, simplest design. So cost also low cost. So low cost design. It is also low cost design. Low cost design. Okay, low cost design. So used in memories. Used in memory. Used in memory. Okay, used in memories. Okay, memories and microprocessor programmings, microprocessor applications. So microprocessors. Okay, microprocessors. So microprocessor program stores. So microprocessor applications are used. Okay. So different gate level design. So different combination circuits. Different combination circuits design. Okay, so used in memory. Memory is like ROM, PROM. Okay, PROM, and sometimes we can rewrite the program. So that is electrically erasable. So electrically programmable read-only memory. So we can erase the data. I can rewrite like memories we can use. Okay, so it is for last class we discussed that PLDs are for a ASIC simple. It is for specific applications, right? Specific applications are used. Okay, specific applications are used. So specific applications used. Okay, so we can write down this about PAL. Let us see the block diagram and actual and the schematic representation. Okay, now let us see the PAL diagram. Okay, we can say it is a PAL structure. Okay, Paul structure. Let us see the Paul structure. Okay, Paul structure is and is programmable or is fixed. Okay, and is programmable or is fixed. So let me draw this one. The Paul structure, else we can say, okay, this is AND gate, AND gate representation. Okay, inputs are here. We apply inputs. Okay, so on inputs we are applying. Okay, and outputs are OR gates. OR gates are fixed OR gates. Some fixed OR gates. Okay, so 2 to 20 inputs we may connect to the single OR gate. Okay, so these are the inputs, ma. These are the inputs. Inputs. Okay, inputs we are given to this AND plane. Okay, this is AND plane. AND plane or AND gates. Let's say AND gates. AND gates, and we connect the external OR gates. OR gate is external. Okay, OR gate is external. This is external OR gate or fixed OR gate. External OR gate or fixed OR gates. This is a structure. But previously, PLA is programmable and programmable OR. Programmable and programmable OR. So it is only external we are connecting. So external we are connecting. So we can add input output some other gates, flip-flops, multiplexers, and XOR gates are used externally. Okay. So this is flip-flop. D flip-flop is used. D flip-flops are used. Okay. So let me take this is a D flip-flop. D flip-flop. OR gate output, storage device. D flip-flop is for storage device. So this is for so final output we can take. Okay. So final outputs will be taken. Okay. This is output we can take. Right. So outputs will be taken. So AND gate is programmable. AND is programmable. Programmable AND. Okay. Programmable. This is programmable. Programmable AND. Programmable AND. So according to program, we can write the logic. So according to that AND gates or switch connections. So this is a external we can connect. This is a fixed OR gate. Fixed OR gates. Okay. Fixed OR gates. Fixed OR gate. Okay. Fixed OR gate. So flip flop are for storage device. Okay. Storage device. Okay. Storage device. So storage device is used. So programmable and fixed OR. So external fixed OR, and we can use D flip flops and multiplexers and XOR gates are used, input and output. So in the Paul structure, so added to the input and output. So mux, multiplexer, right? XOR gates, multiplexer, XOR gates, flip flops. Okay, flip flops for storage purpose. Flip flops added to this, added to input and output, input and output. Okay, input and output we can connect these gates. Okay, multiplexer, XOR gates, flip flops added to the input and output in this PAL structure. Only AND gate is programmable. Okay, only AND gate is programmable with respect to the input, and OR gates, flip flops, multiplexer, XOR gates. These are external gates which can be connected to this. Okay, input and output we can connect. So it is a PAL structure. Okay, so let us see the detailed information about this PAL structure. Right, let us see the detailed information of PAL. Last class we discussed the in detail information like fuse connections. Okay, so three inputs are here. A x complement, x complement. Okay, and x2 complement, x3 complement, x3 complement. Okay, x3 complement. Okay, now how many fuse connections are here? There are 6 fuse connections. Okay, there are 6 fuse connections are here. Last class we already discussed about this. So let us take this one is x1 input, x2 input, x3 input. Okay, so x1 complement, x2 complement, x3 complement. So like fuses we are connection over here, like fuses we are connection over here, right? 2 and 3, 4, 5 and 6 more. Okay, and we can take this fuse connections. Okay, 1, 2, 3, 4, 5 and 6. Okay, this is one AND gate. This is one AND gate. This is a programmable AND gate. Programmable AND gate. Right? Another we can take this another AND gate. 1 fuse connections. 1 and 2. Let us take this 3, 4, 5 and 6 more. Okay, 5 and 6. So 1, 2, 3, 4, 5 and 6 fuse connections. So according to the program, so which can be connected. Okay, so according to the logic product terms the fuse are connected. According to the product term the fuse are connected. So let me take another product terms. So again 1, 2, okay, 3 and 4. You can explain this in external examination, it will be asked you. Okay, and structure you can draw this in detail information about the fuse connections, right? The 6 fuse connections from here to we can connect AND gate. Okay, AND gate. Okay, so we can take all these are to one fixed OR gate. All these are to one fixed OR gates. Okay, all these are to connected one fixed OR gate, right? All these are connected to the one fixed OR gate. One fixed OR gate. Okay, so as we said this programmable, this is programmable and this is programmable AND gate, programmable AND gate, programmable AND gate, and externally this is a fixed OR gate, fixed OR gate, fixed OR gate. So fixed OR gate. So let us take the fuse connections. Let us take the fuse connections. The product term is, let us take this. This is x1, x1 and x3, x1 and x3. Okay, let us take what is the product term here, x1 and x3, x1 and x3. Okay, now let us take second one. Now this is x2, this is x2 from here. Okay, this is x2, x2 and x3 complement, x2 and x3 complement. So product term x2, x3 complement, right? Let us take this x1. Anyone we can take the connections. So according to that, the fuse connections. According to the product term, the fuses are connected. Okay, so this is x1 and let us take this x2, x1, x2 and x3 complement. This is x3 complement. So 3 fuses connections. The product AND gate is x2, okay, x1 and x2, x1, x2 and x3 complement, x1, x2 and x3 complement. You see, so according to the product term program which we can write, the fuses are connected over here. The fuses are connected. The fuses are connected to this AND gate. So as inputs are increased, the fuses are increased. Okay, so these are the inputs. These are the inputs. Okay, these are the inputs and the AND gates, fuse connections and external OR gate, so each OR gate can be taken. Okay, so 2 to 50 or 2 to 50 inputs may be taken. Okay, OR gate. So product terms we can use up to 32 product terms. So up to 32 product terms, input 16-bit input is taken. So OR gate, each OR gate it will be taken to 250. Okay. So OR gate output. This is OR gate final output. The function output. The function output. Let us take F1. So what is the F1 function? So F1 function is equal to all these product terms. R of all the product terms. All the product terms. So what is the product terms are here? X1, X3 plus X2, X3 complement plus X1, X2, and X3. Okay, X1, X2, and X3. So this is about in detail information of Paul. So detail structure of, you can say this is a detailed structure of PAL. Okay, so detailed fuse connections, programmable fuse connections, programmable switches. So detailed structure of, okay, detailed structure of PAL. Okay, PAL, programmable switches, programmable switch connections. Okay, so these are the programmable switch connections, right? Programmable switch connections, programmable, okay, programmable switches, programmable switch. So according to program which we can write for this product term, so the switches are connected, the output product term will goes to X1 and X3, X2, X3 complement, and X1, X2, X3 complement. Okay, so which is given to the OR gate. This is external OR gate. Okay, now, so in the PAL, inputs are 16 possible, 16 inputs, 16 inputs. In PAL structure, okay, in PAL structure, 16 inputs can be taken. Okay, 16 inputs, 16 possible inputs. Okay, 16 inputs. We can take same 32 product terms, AND gates, 32 product terms. Okay, product terms, and we can take so 8 number of OR gates, 8 number of OR gates. Okay, 8 number of OR gates. Each OR gate can be taken. Each OR gate. So 2 to 50. We can take 2 to 50 inputs. So 2 to 20. We can say 2 to 50 or 2 to 20. Okay, let us take 2 to 50 inputs. 2 to 50 inputs OR gates will be taken. Each OR gate can be taken. External OR gates. Okay, so we can also use the multiplexer. We can also use the multiplexers and XOR gates, flip-flops in the designing. So only AND gate is programmable, remaining are externally connected. This is about the PAL structure. Okay, you can explain. It will be asked in examination. You can write about what is PAL, and where it is used. Okay, all this you can write definition and all. Then the structure. Okay, PAL structure, the in detail structure of fuse connections, and also let me go for and see this one. PAL schematic representation, schematic diagram. Okay, PAL schematic diagram. Sometimes then we can basically in the problematic we can discuss about this schematic structure. So PAL schematic structure, right? PAL schematic structure. PAL schematic structure. In problems, we can represent this in problems. Okay, so how it will be, and we can then this structure can be used. Okay, right? Let me see the structure x1 and x2 and x3. x1, x2, and x3. Okay. x1 complement, x1 complement, x2 complement, x3 complement, x3 x3 complement. Okay, so in the problematic, when we are discussing the structure, we can schematic structure, we can also represent this. Okay, this is x1, x2 and x3. So it is a complement, x2 complement, x3 complement. Okay, so let me take the, how many gates we previously are taken? 3 gates. Let us take this one. Let us take these 3 gates. Okay, 1, okay, and 2, anything we can take one. Okay, 3 and 4. Okay, let me take the 4 gates are here. Okay, so which may be connected these to the OR gates. Okay, which may be connected to the OR gates. Let me take another gate also. Okay, so it is a schematic representation. So depend on the product terms, depend on the product terms which we can be used. Okay, which we can be used for OR gate. Okay, output is connected to the OR gates, right? So let me connected this one is connected to one OR gate, connected to one OR gate. Okay, and let us, these three product terms are connected to, these three product terms are connected to one OR gate. Okay, so one OR gate. So you can use 2 to 50 like. Okay, so let us take this one, the cross mark representation, the product terms and the external OR gates. So let us, this is function f1, this is function f2, this is function f1 and function f2, right? Function f1 will be taken x1 and x2 ma, x1 and x2. So function f1, the first product term x1 and x2. Okay, x1 and x2, right? The second product term, let me take x1 complement and x3. Okay, so this is x1 complement and x3, x1 complement and x3 product term. Okay, so then function f1, so function f1 is equal to, function f1 is equal to, what is the function f1 according to the product terms? So r of the product terms x1, x2, x1, x2 plus x1 complement and x3, x1 complement and x3, which you are connected over here, a cross mark. Okay, so there is no fuses. So fuses, it will be in detail information, in detail information. So programmably connected switches. So when you are doing a problem, then we can easiest way to, we can represent this one. So easiest way to represent. Okay, then the f2 function, let me take this x2, x2 and x3 complement, x3, x2 and x3 complement. So this is x2 and x3 complement, x2 and x3 complement. Okay, anything we may take, then it is AND gate. Okay, so for example, let me take this x1, x2 and x3 complement. So x1, this is x1, x2, x3 complement, x3 complement. Okay, then third and another third AND gate for this f2 function. Okay, so x2 complement, x3, x3 complement. Okay, so this is x2 complement, x2 complement, x3, x3 complement. Okay, so we can write the function of f2. Function of f2, the product terms are, so this is x2, x3 complement, x2, x3 complement plus x1, x2, x3, x1, x2, x3 complement plus the product term is x2, x2 complement. Okay, x2 complement, x3 and x3 complement. Okay, so according to any function is given f1, f2. So according to that we can connect the cross mark, and then which will be goes to the AND gate. So AND gate is a programmable, OR gate is external fixed OR gate. So this is a fixed OR gate, fixed OR gate, and up to this is programmable. So up to this is a programmable. So programmable and plain. So programmable and gate. Okay, right? Programmable and gate. So programmable and gates. Programmable and gate. These are the fixed OR gates, external OR gates. So we can also draw the schematic structure of this. So inputs and outputs. These are the inputs and output is OR gates are the outputs. Two functions F1 and F2. Okay, and the gates. Okay, it will be asked in the examination. You can explain all this, right? You can explain all this, right? And in detail information also you can explain. In detail information also you can explain. Okay, so Paul is programmable and fixed OR. So it may be used in memories, microprocessors for memory applications, microprocessor programming. So programming languages are stored in this. Specific applications are used, right? So please subscribe our channel. Okay, like and inform to your friends. Thank you.